Good evening, Professor. Me and my teammates, Pujita and Rahul, are here to explain about the code and give the overview of the project. So, the topic of project is neural machine translation. It's a well recognized technique we use to leverage any advanced neural network architectures to deliver unparalleled accuracy and fluency. In this project, particularly, we took some examples like converting French language to English, French as so French as a source language and output as English language. And deep into the project, before into the project, I'd like to explain what is neural machine translation and we are, what are like we use in this project. So me along with my friends Pujita and Rahul will be explaining further slides. And after a completion of the explanation, neural machine translation involves a sequence of steps to translate a French sentence into English using some models. And here we use like embedding, attention mechanism, output sequence, post processing, and many more to do this. Like I can explain step by step what's embedding and also tokenization. Tokenization means break down the input sentence into individual words step by step and units so that it helps us to reach the output easily. And embedding converts each token in a high dimensional vector using pre-trained word embedding. This vector captures the semantic meaning of each word. But my friend Pujita will take from here and we will go step by step. After that, me and my friend Rahul will can explain the code part. Pujita, it's up to you.
In this project, we are going to use Jupyter Notebook for executing the code. We are providing some libraries. Import OS means operating systems. These lines import standard Python libraries for dealing with the operating system's OS. Import RS, regular expressions. Import pickles working with and handling zip files, managing dates and times, and working with Unicode data. Import NP means NumPy and PD means pandas. These libraries are imported. NumPy and pandas are commonly used for numerical and data manipulation tasks, while TQDM provides a progress bar for loops, which can be helpful when processing large datasets. These libraries provides functionality for working with the operating system's regular expressions, dealing with zip files, and working with the Unicode data. It can be useful for tracking the progress of lengthy commutations, and these are data visualization libraries. Here, matplot inline is a Jupyter Notebook magic command that ensures that plots are displayed in the notebook. Seaborn and matplotlib libraries for data visualization. Here, import TensorFlow keras optimizers, import Atom, import clear session, import model, import embedding LSTM, text import text tokenizer. TensorFlow is imported for machine learning tasks. Specific components from keras, which is integrated into TensorFlow, are also imported. This includes the Atom optimizer clear session to clear the keras session, model for defining models, various layers, and utilities for text processing. It imports callbacks for training monitoring such as TensorBoard and early stopping. In line 2, clear any logs from previous runs. This command is a shell command that removes the contents of the logs directory. The rm command is used to remove the files or directories, and the rf stands for recursive and force. This line ensures that any previous logs from the tensor board are cleared before starting a new run. Here we have some parameters like data, size, num row, num columns, data containing numerical features, size containing overall figure, number row contains subplot grid, number column defines the subplot column grid. This function is used to generate a grid of box plots for numerical features in the provided data frame. This plot analysis is used to create a box for the numerical features in the data frame.
Yeah, splitting of data. Yeah, from the above code, this uses the train test split function to split your data, our data into the train and validation sets with 95% of training, like the X train, and the 5% of X value for validation. It creates separate list for English and French sentence in both training and validation sets. And also, this function performs several pre-processing steps on given sentence. It calls the Unicode to xi function to convert uni character to xi. It uses regular expressions to add a space before certain punctuations and all. Overall, this function uses are useful for preparing data by normalizing Unicode, especially when we work with the sequence-to-sequence model for tasks like machine translation, which is helpful in getting the desired output from the beginning to end of the sequence. And also, it looks like we are using a pickle model to serialize and save preprocessed training validation from the above code, and it's clearly explained by my friend Pujita. And also, a little bit down, yeah, the preprocessed English input sequence for training. That's also we can see from the above code. This line saves the preprocessed English output sentence for training to a file named called trained English output one, train in English, train English in. All the file names are above seen clearly to get the desired output. It looks like we are having various deployment and testing models, and to get the proper form of output with the everything we are using in this, like commas and exclamation marks for the in the output. And we also make sure to open the files in a binary model for like RB, and we remove whatever the directories and file from RM from the above code. This way we can rescue the tokenizer without need to fit them again on the data, which can be beneficial when you want to use it and tokenization scheme during testing and deployment. That's all about my part. Rest my friend Rahul will take forward.
Hi, I'm Rahul, and I will explain from here. This Python code sets up Keras callbacks, tensor board for visualizing model training logs, and early stopping to halt training if no loss improvement occurs within 2 epochs, helping improvement helping prevent overfitting during neural network training. This Python code crafts an encoder decoder model using a Keras, comprising an encoder to process input sequences, a decoder for generating output sequences, and a combined model linking the two. It trains the model, visualizes the training process, and saves the trained model weights, accumulating in a visual deception of the training loss across epochs to gauge the model's performance. This code defines a prediction function using an encoder decoder model for translation tasks. This function processes inputs sentences, tokenizes them, passes them through the encoder and decoder parts of the model, generating translated output sequences word by word until